Hey there, it's Crop. Welcome back to the Crop channel, and as you can see, I'm making another math tutorial video for you guys today. So guys, today I'm making a video, and I know it's been a while since I posted, a year and a half, but don't worry, I got a video for you guys. But unfortunately there were some issues with the camera, there were some focusing issues in the first part of the video, but later on I was able to fix this. So I hope you guys can forgive me for that. So today I'm going to be teaching you guys about the derivative of a constant to the power of x. So let's say, and then that will lead on to the derivative of e power x. So let's say we have y is equal to a power x. So then if we take natural logs of both sides, we'll be left with ln y is equal to ln a power x. The reason why we take natural logs of both sides is so that we will be able to differentiate this, because we know how to differentiate natural logs. So we're going to have to use implicit differentiation over here. But first, let's use our log rule to change this. So we're going to leave ln y as is, and then make this x times by ln a. So this is using the log rule of log b times m power k is equal to k multiplied by log b, base b, times by m. That's basically what we did over here. But instead of log of base b, we have log of base of e, because that's what natural log is. So now we use implicit differentiation. So basically, the implicit differentiation of ln y becomes 1 over y multiplied by dy by dx. The reason is because the differentiation of the ln function is the differentiated of what's inside over the original function. So that's 1 over y. And then the derivative of the inside function. So that's 1 over y, because that's the derivative of the ln function, multiplied by the derivative of the inside function, is equal to ln a. The derivative of x is just 1, so we leave that as ln a. So then, if we multiply these, we have dy dx is equal to ln a multiplied by y, and y is equal to a power x. So that leaves you with a power x times by ln of a is equal to y. And now, if we want to prove that the derivative of e power x is e power x, then we just substitute a with e. And ln of e is just 1, because log power e, log base e to e is just 1. So that leaves you with e power x. So you could also prove that the derivative of e power x is e power x using the limit formula. So limit as h approaches 0, you could use delta x instead of h. Some people do that, but it doesn't really matter. And I'm going to use this formula to prove that e power x is the derivative of e power x in another video. So tell me guys if you want to know how to do that, and I'll make a video on that and the proof of the limit formula as well. To consolidate your learning, let us look at an example. Y is equal to x power x. So as we said, we take natural logs of both sides. We use the log rule to bring down the x. As you can see, the x is multiplied by the ln x, so we have to use the product rule. So I'm assuming you know what the product rule is. If you don't, then I advise you to look at some tutorials online. So u equals x, u prime equals 1, v equals ln of x, v prime equals 1 over x. That is just writing out the product rule for ln of x. So if we multiply them, we get ln of x, we cross multiply them, then we get ln of x plus x times 1 over x. And that just simplifies to ln of x plus 1. But we have to find the derivative of ln of y. So that's just 1 over y times dy dx, as we discussed when writing out the proof for it. So, just as a recap, the product rule, we use the product rule to find the derivative of x times ln of x, which gives us ln of x plus 1. So now we need to find dy dx. So dy by dx is equal to ln of x plus 1 times y. And as we said earlier, y is equal to x power x. So that leaves us with x power x multiplied by ln of x plus 1, which is the answer. So now we're going to prove that the derivative of tan x is sec squared x. So, what is tan x? Tan x is sin x over cos x. For those of you that are skeptical about this, I'll draw a little triangle and do the proof of that. So, sin x, wait, this is adjacent, this is opposite, and that is hypotenuse. AOH. So, sin alpha is equal to opposite over hypotenuse. This is just basic SOHCAHTOA, basic trigonometry. Sine is the opposite of hypotenuse. Cosine is equal to adjacent over hypotenuse. And tan alpha is equal to opposite over adjacent. So, if you divide sine by cosine, you will get tan. So, O over H divided by A over H. If you take the reciprocal, that becomes O over H multiplied by H over A. The H is cancelled to give over A, and O over A is equal to tan alpha. So now that we've established that sine over cos is tan alpha, sine over cos is tan x, sorry, let's go on to the differentiation and calculus part. So we're going to have to use the quotient rule. Whenever you see a fraction, you use the quotient rule. So the quotient rule is v times by du dx minus u times dv dx, all over v squared. That is the quotient rule. So u is equal to sin x, which is this part, and v is equal to cos x, which is that part, because quotient rule is used for fractions. So v times, so v is cos x multiplied by du by dx, and du by dx is cos x. So the derivative of sin x is cos x, and we can prove that using limits, but that should be for another video because it's a lot more complicated. Minus, tell me guys if you want to see that, minus u, which is sin x, times by dv dx, and v is cos x, so the derivative of cos x is minus sin x. This can also be proved using limits, all over v squared, which is cos squared x. So we just substituted in the values instead of u, v, dv, dx, and du, dx. So let's simplify. Cos squared x plus sine squared x over cos squared x. So basically, cos x times cos x is cos squared x. Sine x times minus sine x is minus sine squared x, times by minus 1, which gives you positive sine squared x. So cos squared x plus sine squared x is 1. Cos squared x plus sine squared x is equal to 1 due to the trig identity, and 1 over cos squared x is equal to sec squared x. So to recap, sine squared x plus cos squared x is 1. 1 over cos squared x is sec squared x. If you are skeptical about sine squared x plus cos squared x equal to 1, then we can go back to our triangle. This is alpha. This is adjacent, this is opposite, and this is hypotenuse. So, sine alpha is equal to opposite over hypotenuse. Therefore, opposite is equal to h times sine alpha. Cosine alpha is equal to a over h. Therefore, a is equal to h times cos alpha. And due to Pythagoras' theorem, a squared plus o squared is equal to h squared. And we have o and a, so we can substitute those in. H sine alpha squared plus h cos alpha squared. Remember to put the brackets, equals h squared. That gives you h squared sine squared alpha plus h squared cos squared alpha equals h squared. If you factor out by h squared, if you divide both sides by h squared, you get sine squared plus cos squared is equal to 1. And then this relates to this, and then we get our proof. So you guys may have learned that the derivative of cosec x is equal to cosec x minus cosec x, multiplied by cos x. So I'm going to prove that today. So what is cosec x? Cosec x can be written in the form of 1 over sine x. That's just rewriting cosec x in terms of sine. And if we change that into the power form, in terms of power, then we get sine x power minus 1. That is what cosec x is. So now this is where the differentiation starts. We're going to use the chain rule. So y is equal to sine x power minus 1. So if you're unfamiliar with the chain rule, I would advise you to look up some tutorials online, because this part seems that you are already familiar with the chain rule. So we're going to label sine x as u. Y equals u. So now dy by du. Actually, let me fix that. Yeah, so sine x is u, so y is equal to u power minus 1. If we do dy by du, then we get minus u power minus 2. So that's one part of the differentiation done. Now we need to differentiate the inside function. So u is equal to sine x. Du by dx is equal to cos x. So now that we have dy by du and du by dx, we have to find dy by dx, because that's what we want. We want the derivative of this with respect to x. We want the derivative of this with respect to x, so that is dy by dx. This is du, by dx multiplied by dy by du. The du's cancel out and we're left with dy over dx. So we just multiply them and we get minus sine x power minus 2. That is what the dy by du is. Multiplied. Let me fix that too. It's a bit odd. Times by du by dx, which is cosx. That is equal to dy dx. So now if we simplify this, we'll put it in terms of fractions now. So minus 1 times 1 over sine squared x times cos x. 1 over sine squared x is sine x power minus 2, minus 1 times by that, times cos x. So, that gives you minus 1 times by cos x over sine x. And we know that cos x over sine x is cot x. But then, we're left with 1 over sine x, because we used the second sine x for cot x. Cos x over one of the sine x's gives you cot x. So you're left with 1 over sine x as your remainder. And that is cosec x. We know that 1 over sine x is cosec x. So then if you just bring all this together, you are left with minus cosec x cot x, which is what we have over there.